Okay, let's start chapter 3. But you guys have followed mostly, right? What I have said in chapter 2. I hope you guys noted it down. Okay, so in chapter 3, so definition of the multiple linear regression model. So here, as you see, there are this like dependent variable or we have different names for the different dependent variable. We also call it explain variable or response variable. Okay, so you will see different things, and here we have independent variables. There are like multiple independent variables, so beta 1, beta 2 up to beta k, and of course we will also have the error term, the u term, right, in a regression model. So motivation for the multiple regression. So now we have multiple explanatory variables. Okay, in the simple regression model, we were only considering one explanatory variable, right? Like how wage is affected by different factors. Now we have multiple. So the main reason for multiple regression analysis is to include as many explanatory factors into the model, more explanatory factors. In fact, when you guys are writing your term paper, I expect that you guys at least have at least 4 explanatory variables. Okay, don't just write a paper with one explanatory variable, then you won't have much to write, right? For each explanatory variable, you might have to review 2 literature, like 2 papers for each explanatory variable. So if you have 4 explanatory variables, you need to review 8 papers and you have to cite them. And here we have to hold fixed other factors, okay, and allow for more flexible functional forms. Okay, if you guys take an advanced level statistics course, you will also see that they have interaction terms. Okay, so let's say in this example, like the wage equation, they are trying to analyze how education is affecting your wage or how experience is affecting the wage, right? Now the interaction term could be, let's say, how both this factor, education and experience, let's say beta 3, and it's a dot or times. In that case, we will capture the combination of the two, like how both of them are affecting the wage. So you can even get like an interaction term. Okay, so there's a lot of flexibility here. So if we write a model, let's say if we are trying to find the impact of a policy before and after, let's say like a health policy like Obamacare, right? So before and after, we can make use of the interaction term, like how that has affected the general population in their, let's say, to improve their health outcomes. So let me give the example. So health outcomes, HO, so beta 0, which is the constant term, plus beta 1 Obamacare, right? Let's say beta 2 insurance enrollment, right? And then we can create an interaction term, beta 3 with Obamacare and insurance. So when Obamacare, people did not take Obamacare, the beta 1 coefficient would disappear, right? This coefficient would disappear if there is no enrollment, right? When Obamacare is 0. So if Obamacare is 0, what would happen to the beta 3 term? Beta 3 term would also disappear because Obamacare is 0. So when there was no Obamacare, people still had insurance, right? I mean, people would have health insurance regardless of if they don't have Obamacare or if they don't have Obamacare. So the beta 3 term will also disappear when Obamacare is 0, right? Let's say OB. But the insurance term will be remaining there, right? So the insurance term would capture the effects when there was no Obamacare. Agreed? But when Obamacare is 1, then the beta 1 term, this term would remain, and the interaction term of Obamacare and insurance will also remain. Okay, in that case we can find the effect only with Obamacare, and also like when people have insurance and Obamacare. Right? So I will talk more about the, in fact let me write it on the board, it will get clear in fact, right? In fact, let me use an education example. It's easier. Let's say that's the problem, right? No class. Actually, I'm carrying. Bad luck. Okay, let me do it in the paint then. Okay, so let's say, oh, you guys are not seeing that, so let me end this. Keep. Let's say we want to analyze the GPA of students, okay, and how GPA is affected. Let's say they have a beta 0 and beta 1 when the there is only instruction in class, so only class instruction, so CLASS INST instructions, again short I'm writing, and let's say the department decided that class instructions are not sufficient, they should also give like some lab sessions, so beta 2 lab, and as usual we have the error term U, right? So then if we want to see that with lab and without lab, so with lab this beta 2 would be there, right? So these would capture the effect of the GPA based on your lab session, right? And when lab is 0, you will get the effect without the lab, right? So let's say in this econometrics class we don't have any practical examples, like we don't take any like status sessions. Maybe you guys will learn the topics theoretically, right? But you can't apply it if you don't have the statistical skills or the software, right? That would affect your GPA overall in the long run, maybe, because later you might get demotivated and think that, yeah, I can't write a paper, I don't know how to use it, I know the theory but I don't know how to write a paper, right? So in advanced classes, let's say you go and take advanced level graduate course, and over there if you didn't have the lab session in the undergrad, what would happen? The worst case scenario, you won't be able to write a paper, right? Because you know the theories but you don't know how to apply it. So without the lab, your GPA would be, let's say if you didn't have the lab, maybe your GPA would be 2.5. But because we have lab sessions, these lab sessions would help you to get like better at writing and writing a paper or analyzing things. So in the long run, with the lab sessions, your improvement, let's say, is 3.0. Okay, these are all hypothetical assumptions. Okay, in real life I would want all of you guys to get like a 4.0, but these are hypothetical situations. So with lab, without lab. Now what's the problem? The problem is that if we don't have an interaction term, so if we had an interaction term like beta 3 lab times class instructions, this extra term, this beta 3 term, is capturing the cumulative effect of both lab and class instruction. So if you are attending lab and as well as attending the class instructions, that would have a larger effect on your GPA. Agreed? Right? You have to attend both. You can't be like, no, I just attend the lab and I don't need to attend his class sessions, because then the problem is you won't understand what's happening. Like that might not be useful for you. So that's why the interaction term can capture the cumulative effect of both labs and the instruction. Let's say you don't attempt labs, so you 0 for lab, but you attend class instruction. In that case, what's the cumulative effect? 0, right? Because you didn't attend the lab, and only class instruction is not sufficient for you to capture the cumulative effect, right? Let's think about another situation. You are the type of person that, okay, I'll just attend the lab for this guy and I will not attend his class instructions. Again, your cumulative effect would be 0, right? You are only getting benefit from the lab in this case. You're not getting benefit from the class instruction. Now, if there is a serious student, right, they attend, let's say, both lab and class instructions. Now you can capture the cumulative effect, like how both of them have complemented you for attending a higher GPA. Okay, attaining a higher GPA in that case, not attending but attaining a higher GPA, right? So that's why we can use an interaction term. So in my health example, like we can use a lot of interaction terms. So these are important for your paper. So let's say total health expenditure, BMI, beta 0 plus beta 1 BMI plus beta 2, let's say smoking, and let's say you want to have a cross interaction term, so beta 3 BMI and smoking plus the error term. In this case, we can observe the cumulative effect of both smoking and obesity. If someone is obese and they are also smoking, is the worst possible outcome they can have in terms of their health outcome, right? Like if their obesity is more and also they're smoking at the same time, we can capture the cumulative effect of both of them together. Okay, it's like a snowball kind of effect. And also we can capture the individual ones, the individual effects and the joint effect. Okay. Sometimes one, in fact, not smoking, let's say if it was, instead of BMI, it was drinking. Okay, these are more complementary in nature, right? If you're drinking, maybe there's a likelihood you're also smoking more. In those kind of analysis, these cross terms are really important. Right? Is that clear to all of you guys? So it can take different shapes. So let's go back to our okay. So per student spending, like if we look at this example, like the average score depends on how much they're spending at this school, as well as maybe their average family income of the students. So if their average family income is higher, obviously maybe like they can afford to have more resources, and that will help them boost their average score, right? And if they're spending more, like education is like an investment. why are you guys spending like money to get education? Because all of you guys want a higher wage or to get a good job or something like that, right? So so if they're spending more, their average scores would also go up. So spending could be like, let's say they have tutors at home, or they take more classes or things like that. So that helps, like if you have tutors, things like that, right? Okay, so what's the problem when we omit the average family income in regression? It would lead to a biased estimate of the effect of spending on average test score. So if you are excluding like an important factors, you are not even looking at like important factors and you are omitting them, then that will give a biased result, right? So because here if you look at this, that per student spending is likely correlated with the average family income at a given high school because of school financing. So in Michigan, the like rich neighborhoods, let's say Bloomfield Hills, the average family income would be really high because all the doctors are living there. And you will also see a trend that those doctors are also spending more on their kids' education or on their children's education. Uh, so we can't omit like important variables from the regression. Otherwise, it would lead bias estimate. Okay. So in a simple regression model, so now they are going back that effect of per student spending would partly include the effect of family income on test scores. So per student spending in a simple regression is like a subsample of like total spending, right? So it would only partly include the effect of family income on test scores. Okay, if you don't have average family income, then you can only say that okay, because of spending, the average score has gone up to this much. But within that spending, part of it would come from the family income, right? Not all. But once we include the family income, then we can capture the family income effect directly, right? Let's say we don't have beta 2. Okay. Let's say you didn't include the average family income. Can you make any can you make any let's say estimation based on family income, how family income is affecting the average scores? What do you guys think? We can only estimate a part of it. We can say that maybe spending per student spending, like family may contributes a portion of per student spending, right? Because some comes from the government, like if they are public schools, obviously state is subsidizing the schools. Like it's really funny that the states are subsidizing schools in only like rich neighborhoods, maybe because they are collecting more taxes in general, right? But let's say in Detroit public schools, I don't think they spend enough here compared to the rich neighborhoods. Okay, they should. I mean, obviously in terms of equity and if you most of you guys did the like the principles of macro, right? You heard about equity and things like that. But unfortunately, like it would be nice if they can spend like more in most schools in general rather than just in the rich neighborhoods or things like that, right? So if I exclude average family income, I cannot directly measure the effect of family income on your test score, right? If that's my objective, that I want to see how the average family income is affecting the scores, there is a linear relationship, a strong linear relationship. If you are coming from a rich family, you don't have to worry about loans or things like that. Your decision making gets easier. Whatever schools you get into, you can easily attend that. In fact, it creates brand value, right? Let's say you go to Duke and take a master's in business, right? Like an MBA. Okay. And maybe you're smart, but if you're poor and like you go to a state school and you go to a private school, when the employer is hiring, their chance of hiring would be because of the brand name. They won't look at the quality, right? First thing would be the brand name. They can look at the quality once only you are hired by the company, right? Can they judge your quality just based on your GPA score, right? So if you guys go to a graduate school, my advice would be try to go to a good graduate school like the top 20s or 30s, because brand value matters in the job market. Okay, if you go to a state school, only maybe the state would know, like let's say Wayne State, people in Michigan would know about Wayne State, but let's say you want a job in New York or in California or Washington DC, then they will only know the top 20 or 30 names, right? And you can't blame them because there are 4,000 universities in the United States. They can't know all the 4,000 universities name. So that's one advice. So okay, next is, if you are looking here, we also have an income square in this estimation method. So family income and family consumption. So they have income squared. So model has two explanatory variables. We have income and income squared, right? Consumption is explained as a quadratic function of income. Why quadratic? There is a squared term, right? And one has to be very careful when interpreting the coefficients, which is the change in consumption with change in income. When we are doing that, it's like a differentiation. How many of you guys are familiar with differentiation? All of you guys know the differentiation, right? So for beta 1, it's just beta 1, and beta 2 income square, it becomes 2 beta 2 income. Okay, something like if it is 2x squared, let's say I want to differentiate x squared, it becomes 2x1, right? The 2 comes in forward and we subtract 1 from here, right? That's how we get twice x, right? If you want, let's do it there. So I'm just going through the basics, although I assume all of you. So what's the differentiation of x squared? The 2 would come in front, right? 2x squared, and then 1 is subtracted from here. So ultimately it's twice x, right? What's the differentiation of x cube? Let's use a different color. X cube. All of you guys are familiar with this? So 3 would come in front and we have to subtract 1 from the that part, so it becomes 3x squared, right? Is it clear? It's very basic, but you need to know this, because we always like the change in y with change in x. As economists or as like, we always want to know what's the change in y. In this case, what's the change in consumption with respect to the change in your average income. Okay. Okay, is it clear for everyone? Is it a linear relationship? No, right? There's a quadratic term there. So it's not linear. Okay, and another example is the log. So we have log of salary, CEO salary on the left hand side, the dependent variable, and we have log of sales and quadratic function of CEO tenure with the firm. What did I tell you guys, that when both the terms have log form, then the change in salary with respect to, let's say, change in sales would be the beta 1, or in fact we will get the elasticity directly, right? So beta 1 would capture the elasticity of salary with respect to the sales. So the model assumes a constant elasticity relationship between the CEO salary and the sales of his or her firm. Okay. And so assumes a constant elasticity, and that constant elasticity is captured by beta 1, right? And next part is the model assumes a quadratic relationship between CEO salary and his or her tenure with the firm. Okay, so with tenure they have a quadratic form. So meaning of the linear regression, the model has to be linear in the parameters, not in the variables. Okay, so the parameters should be in linear form, okay, not the variables. So let's look at the OLS estimation of the multiple regression model. Once you have a multiple regression, the first one is it should be randomly sampled, right? Like all the explanatory variables that is collected is done randomly, right? Not with any particular preference or order. And now the regression residual is, you have subtraction from all the estimates of the explanatory variables. So beta 1 had xi, beta 2 had xi2, beta k had xik, right? And that's the regression residual. And minimizing the sum of squared residual, and basically this minimization process would be carried out by the computer. Okay, so like Stata can do that easily, the minimization. We don't have to do this with hand. In fact, in graduate school they teach us how to do it with hand, all right, like in matrix form notations. Okay, you guys don't need it, so don't panic. I'm not going to ask calculate the minimization of the error terms. Okay, they teach us, but hardly we use it. Like we rely more on the computers, the Stata. Right? You can calculate using the matrix notation. And like we interpret, how do you interpret? So how much does the dependent variable change if the jth independent variable is increased by 1 unit, holding all other independent variables and the error term constant? So this could be a potential midterm, not midterm, but the final question is that we have to hold all the other independent variables and the error term constant when we are interpreting, let's say, the like independent variable of a particular independent variable. So if I tell you interpret the independent variable BMI, then the assumption is you are holding other constant, like you are holding access to clean water constant or access to smoking prevalence constant and the error term constant. Only then you can interpret the BMI, right? You can't say that all the other factors are also changing and I want to interpret how the BMI is affecting the total health expenditure, right, in the model that I have used. So explanatory variables fixed even if they are correlated with the explanatory variable under consideration. and it has to be assumed that unobserved factors do not change if the explanatory variables are changed. So ui is constant basically. These are all theoretical stuffs, right? So let's do an example. So let's look at the determinants of college GPA. So college GPA would depend on maybe your high school grade point average and your ACT score, the achievement test score. So interpretation is that when we are just trying to analyze like how high school score is affecting my college GPA, in that case I have to hold the ACT score fixed. Okay, then only I can say that another point on high school grade point average is associated with 0.53 points college grade point average. So when you are interpreting like how high school GPA is affecting college GPA, you have to hold this thing fixed. Okay, and also the error term fixed. Both of these should be fixed. Only when you make that assumption, then you can say that a 1 unit change in high school GPA point would increase the college GPA point by 0.543 units. Here both are in unit form, right? So the interpretation would be like that, right? So or if we compare two students with the same ACT, but the high school GPA of student A is 1 point higher, we predict student A to have a college GPA that is 0.543 higher than that of student B. Okay, this is important. So when I am trying to analyze, let's say how much of hours worked is like affecting your GPA, then I have to keep constant of the other factors. Okay, constant like your intelligence level, because that can affect your GPA in a dramatic way, right? So when we are making analyzing a regression model, I have to hold other factors constant, like your intelligence level, or let's say the type of environment you are in. Like if you are living in a nice neighborhood and they have good public libraries, that would affect your GPA, right? Like you are always having access to those things. So I have to assume that those things are fixed, like everyone has similar facilities. Like assumption is everyone has same type of access to resources, everyone has same type of intelligence level. Only then I can analyze that how many hours of work can improve the GPA, right? I can see the effect of hours worked. Okay, remember this example. I can ask like in the final, like final would be a little bit more technical and theoretical. Okay, but of course like if you are living in a good neighborhood, or if you have a higher intelligence level, even with low amount of hours worked, you can still get a good GPA, right? So properties of the OLS, fitted values and the residuals. So the residuals is always the unexplained part, right? That is not being explained by the model. And the fitted values are the estimated values. So fitted values like beta hat, beta 1 hat, beta 2. So all these fitted values will give a fitted values of yi. We also call them predicted values. Okay. So if I use the word fitted or predicted values, you know I'm talking about the estimated values. Okay. So algebraic properties of the OLS regression. We assume that the error term is 0. okay, sum of the estimated error term. There is this zero conditional mean assumption, or some like the covariance between the deviations and the regressors are 0. Okay. And lastly, the sample averages of y and of the regressors lie on the regression line. Okay, this is important because when you are plotting it, you are assuming that they lie, all of them are lying, the sample average at least lie on the regression line. Okay. And multiple regression analysis also similar to the simple regression, which is the sum of SS, this is should be SST, not STT, right? So correct it in your slides. So sum of square total should be equals to sum of square explained plus sum of square residual, right? And same formula, R square is SSC over SST, or 1 minus SSR over SST. Okay. We in fact got a very good R square value when we were analyzing the health expenditure, right? We got close to 0.45 in the World Bank dataset, right? So what's R square? I'm just recapping. It's how much variation in Y is being explained by the variation in X. Right? What is Y? The independent variable, the dependent variable, and X is the independent variable. Right? I want to point out something. What happens if we add another explanatory variable? Like let's say original model you had total health expenditure equals to beta 0 plus beta 1 BMI plus beta 2 smoking SM, let's say. If I add another variable, my R square is going to increase. But it's a poor tool for deciding whether one variable or several variables should be added to a model. Just to increase the R square, will you guys put all the explanatory variables in the model? Like let's say we have 360 variables in the health, nutrition and population statistics database, right? Like when did I select all the 360? Will it make sense for my model just to increase my R square? No. Choose the variables that you think are important for your model. Don't just choose nonsense variables which doesn't make any sense with your model. It will increase the R square for sure, but that's not the objective. Even the R square is small, still it's good enough if you have a good model, like with few variables, like 4 or 5 or 7 variables. Don't just select that, yeah, he told me that if I add more explanatory variables, the R square will increase. Don't just add all 360 variables and tell me that, yeah, it's a good R square, so my model is nice. Not necessarily. So you have to be careful about what variables you want to add. Okay? So it's a poor tool, okay? So this is also important. It doesn't mean that I can ask, like, can I add more explanatory variables to just increase the R square? Then you can write that it's a poor tool for deciding like if we need to add more or not. So another example is explaining the arrest records. So NARR is the number of times arrested in 1986. So they and if you look at the equation, they have PCNV, which is the proportion of prior arrests that led to conviction. They have P time, which is the months in prison, and they have QEMP, which is the quarters employed in 1986. Okay. R square is 0.0413, which is like 4%. Okay, it's a small R square, but still maybe it's a good model. Okay, and n is 2725. So if the proportion of prior arrests increases by 0.5, the predicted fall in arrests is 7.5 arrests per 100 men. Okay. And if you see that there is a negative sign in front, right? In front of PCNV, there's a negative sign. P time negative sign, quarterly employed negative sign, right? What's the negative sign mean? That means if let's say if you leave, if you are employed, let's say for example, then your number of times being arrested is negative 0.104, right? So if the quarters employed increase by 1, the predicted fall in arrest is 10.4 arrest per 100 man, or 0.104 per man, right? So if you're employed, then your arrest will go down. Makes sense, because you won't have time for doing those activities. It's a classic example. If you spend more time in prison, that would also reduce your number of times getting arrested, because once you are in prison, then the person would think that, yeah, if I do this activity again, then again I will get arrested. So maybe there is some sort of realization in that person that they should reduce the activities to get arrested. So that's also negatively associated. And proportion of prior arrests that led to conviction would also reduce the number of arrests. So if a person was convicted before, then the second time, third time, that person would reduce the activity, and that's why maybe the number of times getting arrested decreases. Okay. Let me see. So today I'll just stop here today, and next class I'll finish the chapter 3. Okay, I'm letting you go early, like 20 minutes early today, but next class I'll finish this chapter. We still have 3 more chapters to finish. We have plenty of time, in fact, and keep working on your paper. I will post some instructions like how to write your paper. I will give you guys my sample graduate level paper. Okay, don't share it with anybody without my permission. But if you have friends who like to write a paper or need help, I'll be more than willing to help, give the permission. Okay, that will give you guys an idea like how to write a paper, how to critique, things like that, right? And has everyone submitted their corrections for the midterm? I will extend the date till November 13th. Okay, originally I thought that I'll put it up to November 10th. So bring it in class.
It's due Friday, right? By Friday?
Yeah, but Friday, yeah, you can send it by Friday. But some of you guys didn't collect the paper, so
I can just submit it like Wednesday, right?
you can submit it anytime. Anytime before is fine.
Yeah.
But make sure by Monday, November 13th, I will give an announcement. And those who wants to take the second midterm, okay, please let me know by Thursday. Okay, I got more responses. So on Friday I'll upload the second midterm at night, and you guys have, it's a take-home exam, so you can definitely improve the scores, and I'll give an average of the two. And submission time is Monday. Okay, so make sure you notify me by November 9th. Okay, if you want to take the exam again. Okay, and those who did the corrections, I'll just add the 5 points to their scores. Okay. So see you guys next class then. And don't forget the homework. Okay, homework is due this Wednesday.
Just wanted to ask, so since I'm doing writing intensive, like I'll be doing a paper anyways, so is there any other, like, things you need to do other than start working on a paper?
You can, yeah, you can, if you want, you can use the paper that you are doing in my class. Like, do you have like Belzer in your, like you told me that you
I'm
were
doing honors thesis with